welcome back to my channel. Last week we have learned about metallic bonding. We have discussed about the electron C cloud model. We have discussed about the band theory of metal, and we also have described and also discussed about the three materials of from what happened from the band of the theory. So for today we are going to discuss or learn about new topic, which is the transition metals. In this part 1, okay, we will be discussing about the electron configuration of transition metal. And in part 2, we will be going to discuss about general characteristic of transition metals. So, as you can see from this periodic table, okay, this is where we have the group 1 and also group 2, the alkali metal and alkaline earth metal. And then we have group 3 until group 12. This is where we have the transition metals. And then group 13, and then we have group 13, 14, 15, 16 and also 17. And last but not least, we have group 18. This is where we have the noble gases. Oh yeah, and then we also have lanthanide and also actinide series. So in this part, we are going to learn how to write down the electron configuration of the transition metals. So as you can see, we have two types of electron configuration. First one is the condensed electron configuration, and second one is the expanded electron configuration. In this code, we are dealing with condensed electron configuration, and this is how we write down the electron configuration. First one, you need to have or you need to determine which noble gases or which noble gas that is the closest one to the metal. Okay, then here it will follow with the ns2 and also the d orbital. As you know, the transition metals, they have usually what we call empty d orbital. So here we have two examples, the vanadium and also the ruthenium. So as you can see from here, vanadium we have 23 atomic number, where the closest noble gas for the vanadium is argon, Ar. Okay, this is already give you 18 electrons, okay, then followed by the 4s2, and then we have the 3d3. This is where we use the Aufbau principle. Okay, this is what we have discussed during our first class, Aufbau principle. Aufbau principle. Then second example, we have ruthenium, where it has 44 atomic number. So the closest noble gas for the ruthenium is krypton, Kr, and then followed by 5s1 and also 4d7. And then other than that, we have the F block sublevel. So this is how you write down the F block, lanthanide and also actinide series. So we have the noble gas, we have ns2, and then we have F group or F orbitals here, F orbital, and then followed by the D orbital. And other than that, for the transition series of period 4, or what we call first row of transition metals, okay, we have two transition metals also. They are chromium, okay, chromium and also copper, where they have exception, involve changes in also in relative energies and also unusual stability of what we call half field and also field sublevel. So as you can see here, chromium, we have 24 atomic number. The chromium has 24 atomic number. So the electron configuration for chromium will start with the Ar. Here we have Ar, 4s1, 3d5. Let me write it down here. Chromium AR 4s1 3d5, and also the copper here 29, this is 24. Copper AR 4s1 3d10. Right, so this is 3. Why? As I explained before, as you can see, chromium, they have a tendency, or chromium, it has tendency to form what we call half fill. This is more stable than partially fill. And also copper, it has tendency to form as 4s1 3d10 fully fill sublevel. Okay, so this is half fill and this one is fully fill. Next, we have here transition metal ions. Okay, the previous one is neutral state or ground state, and here we have ion. So we have a charge here. For example, here we have titanium 2, and then the electron configuration for titanium 2 is Ar3d2, not as Ar3s2. Why? Because we need to remove electron from the outermost shell, which is in this case is, so this is actually 4s2, not 3s2. Please do some correction. Please do a correction on your slide. Okay, so Ar 3d2, not as Ar 4s2. Why? Because we need to remove 2 electron from here, from the outermost orbital. So in this case, the outermost orbital is 4s2, not the 3d2, because we are following the Aufbau principle. Other than that, we have manganese 2 plus and also iron 3 plus. Okay, and their electron configuration is Ar3d5. Both of these two ions are Ar3d5. Okay, this is what we call isoelectronic. They have same electron configuration. Electronic. Electronic. And then as usual, I have exercise for you. Here I have one example for you for nickel 2 plus. For this one, nickel 2 plus. So as you can see, nickel has 28 electron. The electron configuration here for neutral state or ground state is Ar 4s2 3d10. So in order for us to remove these two plus here, 2 electron from these orbitals, so what happened here? You need to remove 2 electron from the 4s2, from the outermost orbital. And what happened here? You get the Ar3d8. So guys, I need you to do the zirconium 2 plus, cadmium 2 plus, and also silver 1, and we will discuss this answer during our class. Then these are examples for the electron configuration for all elements in periodic tables. Okay, and so we are focusing from group 3 until group 12, the transition metal here. And other than that, here as you can see, this is the table 22.1, where you can refer the electron configurations and also other properties for the first row transition metals. And please remember, as I mentioned before, the chromium and also copper exception, okay, to the half fill and also fully fill electron configuration. And then other than that, in this table we have the value of electronegativity, the value of the ionization energy, radius, and also standard reduction potential. So this is where we will discuss or we will learn about the electronegativity, ionization energy, the atomic radius in part 2. So I think this is all for part 1. So I will see you guys in part 2. Bye!